do is to practice the pattern. Let me do one of them. Remember the pattern. Square this. Square that. How do I figure out what goes on there? What's the rule? Do you remember what's the rule?
Y times 9
Times 2. So 9y times 2 is 18y. Now remember, you're going to have two 9y's that get added. So that's how you do that one. How about that? Now this one, I'm having trouble with that. It's a little bit hard. Okay? So I'm going to do one more of them. Let's say I want to do this one. Okay, you want to try this?
Yeah.
What happens here? Right, square the first. So what do I get here? Plus 16, good. And then what? Minus 4 times x. Times 10. Negative 8x. It's a little hard. No, I'm with you. So if you have trouble with these, what's the alternative? Expand them out. Use either FOIL or multiple distribution. You get 49x squared plus 14x plus 14x plus 4. 49x squared plus 28x plus 4, which is the same as squaring the first, squaring the last. This times this, 14x times 2. So that one, you know, this is, again, nice to have if you can do it, but otherwise expand it. Now this one, I want you to do like this. It's a plus or minus, right? Sum and difference. Everything's the same except the plus and the minus. And squared, minus 81. I want us to get where we can just be real quick. What is this guy going to be? What's that going to be? X squared minus 16. What's this guy going to be? Being careful when you multiply those 7 else. Yes.
47x squared minus 1.
49x squared minus 1. How about this guy? What are we going to do with that one? Again, we should be able to do this relatively quickly with this pattern. What do you think?
16a squared.
Yeah. Okay, so this pattern, very doable. You have to think about it at first, very doable. This one's a little hard. So when we get back, we're going to work on some neutrites. To divide polynomials, let's review dividing numbers. Remember long division way back when? What grade? Third grade we did long division. Well, now you guys are automatic at it. You probably don't even think about it. So I'm going to slow it down a little bit. Let's think about all the steps. If I want to divide 3 into 693, and we use this, I don't know what the real term for that is. I call it my division house.
Oh yeah,
It
that's
must
what
have a real name.
cows.
The dividend.
Well, no, this is the dividend, this is the divisor, but just that little thing.
The house of the dividend.
Okay. So what we do, we don't say 3 into the whole thing. Remember, we break it into pieces. So we say 3. 3 times what gives me 6? Right?
Yeah.
Isn't that the question we asked?
Yes.
2. Okay, and again, we're slowing it down. We say, okay, now we do a multiply step. Right? We say 3 times 2 is 6. Then what's the next step? Subtraction, right? So I get a 0, and then what?
Check. Bring down and down.
Bring down step, right? So we bring, and now we kind of repeat. We say 3 times what is 9?
3.
3. Thanks. Then we repeat the whole pattern, right? Multiply. 3 times 3 is 9. Subtract. Getting a 0, bring down a 3. 3 times what is 3?
1.
Then I multiply, I get 3, I subtract. I get 0, and that's my remainder, right? So 0 remainder. If I want to go backwards to make sure it's correct, I can do 231 times 3. If I get 693, I know I've done it right. Let's try a different one. I'm dividing 729 by 4. So we do the same thing. You look at the 4 and you say 4 times what, as near as I can get it anyway, is 7. 1. Do a multiply. Do a subtract. Do a bring down. 4 goes into 32. 4 times what is 32? 8. 8 times 4. We do our multiply step. We do our subtract. We do a bring down. You know, 4 times what, as close as we can get it, is 9. 2. 2 times 4. I subtract, I do have a remainder. Now we had a couple of options that your elementary school teacher may have taught you. They may have said, just write a little R1 here. Anybody remember that, the little R1? So that's one option. The other thing they might have said is, well, you kind of make this decimal, add the zeros that go with the decimal, and then you just keep bringing stuff down until you either don't have a decimal or you notice a pattern, or perhaps you go to the nearest thousandth or something like that. There is another way that I found last class in my only class that knew this. Nobody else has known that you can do this. See this one here, my remainder?
Yeah.
See my divisor, the 4? I can make a fraction.
Oh, yeah.
Take the you remember this. Remainder over the divisor. Who remembers that? Okay, so there were some elementary schools taught this. Some elementary schools did not. Who is this news to? Anybody not see that before? Yeah. So it's kind of cool. I don't know why they don't teach it, because it's a lot simpler than having to bring down all the zeros, right? My fraction's right here. If I were to bring down the zeros, I'm going to get a 0.25. But it's a lot more work. So we're going to, give me a second here. So we're going to actually be using this way of writing remainders when we work at the polynomial. And again, because if we want to verify we're doing it right, multiply. Multiplying, if you have a remainder, then you add in the remainder. We should be good. Okay. What?
Wait till you don't want to use decimal steps.
Well, no, because we're doing this now. What I'm going to do now is I'm going to show you how to use this for
You
polynomials.
don't have to write these decimal steps if you want to.
Yeah, but you don't listen to me.
Okay.
What's going to happen is for numbers, you have a lot of options. For polynomials, maybe not so many. We're going to be using this option. So I want to make sure you all see that. So here's an example of dividing a polynomial by a monomial. And this is a strict polynomial, meaning I have more than one term. And a monomial, remember how many terms are a monomial? Just the one. So watch the steps, because they really are the same process as what we did with the numbers. So you look at the x and you look at the x cubed and you say, x times what is x cubed? X squared. What is x squared? If you're having trouble seeing it, you could just do x cubed over x. What do you get x cubed over x? X cubed, right? Subtract the exponent. All right, so that's finding what to put up here. The next step is a multiply, just like with the numbers. X squared times x, that's cubed. And I'm telling you, if you don't get the exact same thing, you have made a mistake. You're always going to get the exact same thing here. Subtract step. You get a 0, bring it down. My 4x squared. X times what is 4x squared? X times, again, you can do this. You take the 4x squared, divide it by x. So x times what is 4x squared? You got it. 4x, right? Because the 4 comes down, x squared over x is just an x. 4x times x, and we should always get the exact match. Should always come back perfectly like that. Do the subtract, do the bring down. X times what is 5x? I don't know, heard you say it. What is it?
5.
5. 5 times x is 5x. Subtract. There's my remainder. So the quotient here is x squared plus 4x plus 5. Now there is another way to kind of think about this. Yes, sir?
When you brought down 4x,
4x squared?
why did you put the square? Put the square down there.
I did my multiply step. This thing times this thing. 4x times x, just like we did with the numbers. That's where this came from. Another way to handle this is, remember our fractions? Fractions are division too, right? Remember how to do this? If I divide by x, what gets divided by x? Everything. We forgot that? What gets divided by x? Everything, exactly. So I can go this way. X cubed over x. 4x squared over x. 5x over x. We did the same thing? We did, which is a little bit simpler. Yeah, in my opinion. I think this is a little easier. In my opinion.
I like that one a little better.
This one?
No.
This one? The long division?
What? Oh, wait.
I like the fraction better. For me, I see it a little bit easier. And so you have a choice. If you're given divide by a monomial, you can do this either way. Either way is fine. However, for now, we're using long division mostly for the practice of the process. So I'm just gonna do one more example here. 3x times what is 6x cubed?
There you go.
Yeah, so think about it, you know, if you were to divide them. So what would you get? 2? 2x squared. So that's what goes here. Do your multiply step. 2x squared times 3x. You should get the same number back. Do a subtraction step. Bring down. 3x times what is 3x squared? Okay. Let's see. 3x squared over 3x. Right, those cancel out. X squared over x is x. So again, do your multiply step. X times 3x, I get 3x squared. Subtract step. Bring down. When you bring down, remember that sign. That's a minus 12x. 3x times what is minus 12x?
Negative 4.
Negative 4. Negative 4 times 3x is negative 12x. When you subtract, you get 0 remainder. Question?
On a test, if we don't want to be combination and we get one that is in form, do we change over to a classical?
I will say yes unless it says divide using long division. And otherwise, I wouldn't care which way you get it. Okay? So I'm going to kind of leave these for now as well as the U-tries because I want to show you, I want to show you what we do if we don't have a monomial that we're dividing by. I want to do that first. So here I've got x squared plus 2x minus 3. Now I'm dividing by x minus 1. That's a binomial. So I've got a lot of words here, which we'll talk about in a moment, but let's look at the actual example. So x minus 1 is what is our divisor into x squared plus 2x minus 3. So watch very carefully what we're going to do. This is similar to what you do in long division when you have like a big number here. Sometimes you would just kind of round it to a number we understand. So basically what you're going to do is you're just going to look at the x and the x squared. You're going to say x times what is x squared? X times what is x squared? X. So we put that on top. We do our multiply step, but when we multiply, we're multiplying by that entire binomial. So let's watch that. We do x times x squared, and this should always be a match if you're doing this correctly. But now we've got this guy too, x times minus 1. It's minus x. Everybody see where that's coming from? No? Because you're doing x times x minus 1. Right? X times x minus 1. Do the distribution x squared minus x. So that's where that's coming from. Now we have a subtract step. And here's where we are going to be so careful. So careful. Be careful here because remember when we looked at subtracting polynomials? Remember what you had to do? When you were subtracting polynomials, remember how we had to distribute that negative? So you're kind of doing the same thing here, because watch what we're doing. We're doing x squared minus x squared. What's x squared minus x squared? 0. And again, if you are doing your division correctly, you're always going to get a 0 there. Now, watch it very carefully. 2x minus negative x minus negative.
3x.
Right, it's a plus x. I see, Susan. It's absolutely a 3x. Who is seeing that? Because that is tricky stuff. Let me say it one more time. 2x minus negative. A minus is a plus. You want to write the little plus up there, that might help you a little bit. Because I can almost guarantee if you're going to make a mistake, here's where it's going to be. The subtract step. So once you do that, we bring down. This is a minus 3. There's a minus there. And then again, we just look at the x. X times what is 3x? X times what is 3x? And if you're stuck with that, just put 3x over x. So x times what is 3x? Little 1. What's left? 3. Oh. And now we multiply that. 3 times x is 3x. 3 times negative 1. That's minus 3. Do a subtraction, being so careful. 3x minus 3x should always be 0 if you're doing this correctly. Now we're being really careful. Negative 3 minus negative 3. That's a plus 3. What's negative 3 plus 3? There's your remainder. So the quotient is x plus 3. If you multiply x plus 3 times x minus 1, you should get back to our dividend here. So that's x squared minus x plus 3x minus 3, x squared plus 2x minus 3. We get back to what we started with? So we know we did our division right. So things to be careful. When you are setting up these divisions, this polynomial has to be in standard form, meaning you have descending exponents. Multiply all terms in the binomial by the quotient first. When I did the x here, x times x times the minus 1, it is a distribution issue. And this is like, again, the key thing, be very, very careful when you're doing your subtraction. You may want to go ahead and flip sides and add, if that'll help you get there. There's one more little thing, I'm gonna leave it for now. But for now, that should be good. Let's do another example here. So again, I'm getting towards the bottom of page 2. So this is example A. Let's try it again. So you take the x and you say x times what is x squared? A. Goes on top. We do a multiply step. X times x squared, x times negative 1. We do our subtraction extremely carefully. X squared minus x squared. Always should be a 0 there. Here's where we're being careful. 2x minus negative x. That's a plus x, right? So 2x plus x. Bring down the minus 2. X times what is 3x? Plus 3. Multiply step, 3x. 3 times minus 1 is negative 3. My very, 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 very careful subtraction step. 3x minus 3x, again, I always should be getting zeros there. Now I'm really paying attention. Negative 2 minus negative 3. That's a plus 3, right? So negative 2 plus 3 plus 1. This one has a remainder. And now we're going to deal with our remainder the way we did in that example with the numbers, was we're going to turn it into a fraction. So here's my numerator, and the divisor is the denominator. Remember to put a little plus here, though. It's understood when we're working with numbers that there's a plus next to the fraction. Here we have to be a little bit more explicit. So this one is x plus 3 plus 1 over x minus 1. And there was a question over here. Did you have a question?
No, no.
You're going to help me?
Yeah.
Question over there? You're going to help me. Everybody's going to help me. Okay, so who is basically following at least a little bit? Following a little bit. Who's following like a lot? A couple people. Okay, that's good. Let me do another one because I get these tricky. Question?
So, when you have a remainder, you just put that, then B is equal.
Well, let's do one. Let's see. I think this one has a remainder also. So let's do 2x times what is 2x squared? 2. That gives me a 4 here, right? So again, 2x squared divided by 2x. That goes away with x. 2x times x, 2x squared. X times negative 3. Negative 3x. We do a subtract step carefully. You okay, guys? 2x squared minus 2x squared. Again, going to be a 0. I don't even need to put it anymore. I know that's a 0. 11x minus negative 3x. That's a plus 3x. So that's actually 14x. Bring down that negative 9. 2x times what is 14x? That big. 7 times 2x, that gives me my 14x. 7 times negative 3 is minus 21. Okay. My very, 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 very careful subtraction step. The 14x minus 14x. Good. That should be 0. Doing it right. Negative 9 minus negative 21. That's a plus 21. What's minus 9 plus 21? 12. It is 12. There's my remainder. So you had a question about remainder. You take that 12. Remember your plus here. 12 over whatever you were dividing by. And there it is. Yes, sir.
Wouldn't it be like a mathematics, like you
Sometimes you can. If this can reduce it, you do. Yeah. suggestion is like, let's see, it's Monday, should we wait till Wednesday, like lunchtime to open
No
something
way.
up? No. You gotta do at least one or two of these divisions tonight, for sure, that's it.
So, since we're dividing it, trinomial by polynomial.
Yeah.
You're practically looking at the first two, and then you're looking at the last one and the middle one.
Okay. We're undoing this, you mean?
Yeah,
Yes, we are.
it's like you're always looking at the middle one.
What do you mean I'm always working with the camera?
You work with the 2x squared and the 11x, and then you're working with that.
Yes, you're like this, and then you're this. So this one's always included, yeah, you're right. And think about how we get there when we multiply, right? There's two things that have to be, yes, I think. Very good observation. So what they want you to do, the homework is being handed out